When you're factoring, the first thing that you always want to start with is the greatest common factor, or the GCF. So the greatest common factor of an expression is the factor that all of the terms have in common. And we use factors that are numbers and variables. The numbers, we don't use 1 unless we're doing grouping, which we'll talk about later. Other than that, you're taking any common number out, any common variable out, and then seeing what you're left with. So here are some examples. If you look at the first one, you want to look at the numbers first, so the 3 and the 12. Well, they both have a 3 in common. So we're going to take a 3 out. The a squared and the a both have an a in common. So I'm going to take the a out as well. If I take out the 3 and the a, I factor them out, I'm left with an a minus 4. This is as simplified as it can get, and that is my factored answer. 6n squared plus 9n, so 6 and 9, they have a 3 in common. N squared and n have an n in common. I'm left with a 2n plus 3. And the last one, if we look for a GCF, we want to see what all 3 of them have in common. So they all can be divided by 4, but they all don't have an x attached to them. So I can't take out an x. I can only take out the 4. So if I take out a 4, I'm left with an x squared plus a 5x minus a 14. So for right now, we're going to leave that as our answer. And the other type of factoring is when you have a quadratic in standard form, which is ax squared plus bx plus c, where a equals 1. So when a equals 1, we can use a shortcut. So basically what this is saying is you look at your c terms. So we know what a, b, and c are, the coefficients in front of our x squared, our x, and our constant term. We want to see what multiplies to c and adds to b. So you want to find two numbers. So in the example, x squared plus 7x plus 10, two numbers that are going to multiply to 10 and add to 7 would be 5 and 2. So 5 plus 2 is 7. 5 times 2 is 10. Since 5 and 2 work, they're both going to be positives, we can just go ahead and write our factors as x plus 5 and x plus 2. The tricky thing about this is figuring out what signs you need to use. So when the c term is positive, that means that both terms or both factors that we use are either both going to be positive or both going to be negative. When c is negative, one's going to be positive, one's going to be negative. So it's kind of like the playing game. You have to kind of figure it out, and you can write all your options on the side if you're not sure, and just once you get one that is true for both things, which multiplies to c and adds to b, then that's the one we use. So if we look at the first example, we want to see what multiplies to our c term, adds to our b term. So our c term is 20. So we're going to say what multiplies to 20 and adds to our b term, which is 9. So multiplies to 20, adds to 9, but you can use 5 and 4. So x plus 5 and x plus 4. And now it doesn't matter the order you write it in. So if you want to put x plus 4 first and then x plus 5, that's fine. The only thing that matters is that the signs are correct. So let's look at the next one. So our c term is negative 72. So multiplies to negative 72, adds to positive 14. So since our c term is a negative, one number has to be negative, one has to be positive. Since it adds to a positive 14, the larger number should be positive, the smaller number should be negative. So the two numbers that work here would be 18 and negative 4. So we would have x plus 18, x minus 4. And again, the order doesn't matter, but the 18 has to be positive, the 4 has to be negative. Now if we look at this third one, we have a negative x squared. Now, we always want to have x squared be positive. It makes our life so much easier. So what we can do here is we can take out a negative 1. We can factor that out and change all of our signs. So x squared minus 13x plus 12. So now we have to come up with two numbers that multiply to positive 12 and add to negative 13. So since my c term is positive, I know the numbers have to both be positive or both be negative. Since they add to a negative, the numbers should both be negative. So I'm going to use negative 12 and negative 1. So what we're going to do is we're going to keep that negative 1 on the outside that we took out originally. And now we just write our factors, x minus 12, x minus 1. Okay, and then this last one multiplies to our c term, which is 30, adds to our b term, which is negative 11. And again, c is positive, but our b term is negative, so the two numbers we use should both be negatives. So we could use negative 6 and negative 5. So our factors would be x minus 6 and x minus 5. So if we go back to one of our earlier examples that we left alone, okay, now we know how to factor the rest of this. So we have x squared plus 5x minus 14. So in this case, we need to find two numbers that multiply to negative 14 and add to positive 5. So one should be positive, one should be negative. So we can use 7 and negative 2. So we're going to keep that 4 on the outside, and our factors would be x plus 7 and x minus 2. Another type of factoring that's similar to the one we just did is when our a value is not equal to 1. You can use this method even when a does equal 1. We used the shortcut last time because since a was 1, we just had our two factors, and then we would just plug that right in to the parentheses with the x. But in this case, when a is not equal to 1, we have to do a longer step. So we're doing the same kind of idea. We're coming up with two factors, but in this case, we're going to do a times c. So instead of just looking at the c term, we want to find a times c. So a times c is 2 times 12, which is 24. Our b term is 11. So now we want to come up with two numbers that multiply to 24 and add to 11. So that would be 8 and 3. Now, unlike before, we're not going to write this as x plus 8 and x plus 3. Okay? If you do that, let's just do it to show. If we do x plus 8 and x plus 3, if we FOIL this to try to get the original, this just gives me x squared plus 3x plus 8x plus 24. So this gives us x squared plus 11x plus 24, which is not what we started with. So since that's not the same thing, we can't just use the shortcut like that. So this is a big no. We don't want to do that. The way we do this the long way is we take our first term and our last term and we bring them down. So 2x squared comes down, the plus 12 comes down. And we rewrite that middle term. So the middle term that has the x attached to it, the 11x, we're going to use the two numbers that we came up with, the 8 and the 3. So I'm just breaking down 11x, and I'm making it 8x plus 3x. So all I'm doing is kind of expanding this. If I were to go backwards now, 8x plus 3x is 11x, and I get what I started with. So we're just trying to expand this. Once we have four terms, we can use grouping. So by grouping, what we do is we group the first two, and we group the second two. When you're grouping the second two, you want to make sure that you put the parenthesis before the sign. So I put it before the plus. So now we look at each one that's grouped. So if the first grouping, the 2x squared plus 8x, we're going to take out a GCF from that. So 2x squared and 8x, they both have a 2x in common. So if I factor out the 2x, I'm left with x plus 4. Then I look at the 3x plus 12. So whatever sign is in front, so that plus, I want to take the plus out too. So I'm going to take that sign out. If it was a minus, you would take out the minus sign. So you take out the plus. Then you look at 3x and 12 and look for that GCF. So they both have a 3 in common. So I'm going to factor out the 3, and what I'm left with is x plus 4. Now this is very important. What you're left with in the parentheses has to be the same. If it's not the same, you did something wrong, you need to go back and double check. So they're both x plus 4s. So our last step is to take the two outside terms, put them together. So that becomes 2x plus 3. And then the two terms that are exactly the same, the x plus 4s, we just take one of them. And now this is our factored answer. And you can always double check this by foiling it together and seeing if it's what you started with. Okay, so here we'll look at another one. So AC is 4 times negative 3, so negative 12. B is negative 4. So two numbers that multiply to negative 12 and add to negative 4. We're going to use negative 6 and 2. So the first number is going to come down, 4x squared. The last number is going to come down, negative 3. And we're going to rewrite negative 4x using the two numbers. So negative 6x plus 2x. And the order that you do this in also does not matter. So it doesn't matter if you put the 2x first and then the negative 6x second. As long as the signs are the same as what they're supposed to be, it doesn't matter the order. You'll get the same answer in the end. So now we're going to group the first two, group the second two. So the GCF of 4x squared minus 6x, I'm going to take out a 2x. So I'm left with a 2x minus 3. And then the 2x minus 3, well, I want to take out the sign first. I'm going to take out the plus. And then there's no GCF. So since there's no GCF, we're going to take out a 1. So anytime that there's not a number besides 1 as a GCF, we're going to take that out. But when there's nothing else, we're going to take out the 1. So a 1 comes out, and we're left with 2x minus 3. So again, what's in the parentheses is the same. So I'm going to take the two outside terms, 2x plus 1, put them together, and then take one of the 2x minus 3's. There's my answer. Okay, so next one, a times c, 4 times 3 is 12. Our b is 7. So multiplies to 12 and adds to 7. We're going to use 4 and 3. So 4x squared comes down. 3 comes down. I'm going to rewrite the 7x using 4x and 3x. Once I have 4 terms, I'm going to group the first two, group the second two. Take out the GCF from the first grouping, so I'm going to take out a 4x. I'm left with x plus 1. Take out the sign, so I'm taking out the plus. 3x and 3 have a 3 in common. I'm left with x plus 1. Okay, again, the parentheses are the same, so I'm going to put the outside terms together, 4x plus 3, and then the parenthesis terms together, x plus 1. Okay, and then this last one, a times c, 2 times 6 is 12, b is negative 7. So multiplies to 12 adds to negative 7. We're going to use negative 4 and negative 3. So 2x squared comes down, 6 comes down. We're going to rewrite this negative 7x using negative 4x and minus 3x. And we're going to group the first two, group the second two. So 2x squared minus 4x has a 2x in common. I'm left with an x minus 2. Now I take out the sign, so the sign's a negative. 3x and 6 have a 3 in common. Since I took out a negative 3, I'm left with an x, and what I'm left with inside is a negative 2. So make sure that you double check this. The negative 3 times the negative 2 gives me a positive 6. So if you take out a negative number, the sign on the inside is going to be the opposite of what it was. So now the x minus 2's are the same. So we're going to put the two outside terms together, 2x minus 3. And then the x minus 2's are the same. Put them together as 1. And that is our final answer. And the last type of factoring is the difference of two squares. So anytime you have two terms that are perfect squares and you have a subtraction sign in the middle, you want to take the square root of each of them and then write one factor as plus and one as minus. So, for example, in the first one, x to the fourth minus 16, you can take the square root of x to the fourth. That's x squared. You can take the square root of 16. That's 4. So you're going to have x squared plus 4 and x squared minus 4. Now, if you look at this, you can break the second one down more because you could take the square root of x squared, which is x, and you could take the square root of 4, which is 2. So this one, since it only has a plus in there, we can't break that down. So that's x squared plus 4. But the second one, because it has a minus, we can break that into x plus 2 and x minus 2. So this one is now fully factored. If we look at the last one here, 9x squared, well, the square root of 9 is 3. The square root of x squared is x. The square root of 49 is 7. So we have 3x plus 7 and 3x minus 7. So as long as there's two terms, they're both perfect squares and there's a minus sign in between, take the square root of each, and then write the square root of the first one plus the square root of the second one, square root of the first one minus the square root of the second one. Okay, and here's a little chart. So first, you always want to factor out the GCF if you can, and then you have two options, if there's two terms or if there's three terms. If there's two terms, it could be difference of squares, where you take the square root of each, and you use opposite signs, and that's how you write it. Or three terms, when a is 1 and when a is not 1. If a is 1, you can use your shortcut. When a is not 1, you have to rewrite the terms so you have 4 and use grouping.